Welcome, everybody, to what I hope and I believe will be a very exciting event here with Novamera. I'd like to first introduce our guests on the panel, which will be the President and CEO of Novamera, Dustin Angelo, and of course, Andrew Caruana, with the VP of Product and Engineering for Novamera. And we're going to have a bit of a conversation about where they're at and where they're going. And then of course, we'll open up the floor to questions. So if you have a question, I ask that you use the Q&A function at the bottom of your screen. At least that's where it is for me. And then we will address those questions. We also have some engagements with you as well. So we'll have some polling questions in between our conversation that we'd love to have your feedback on as well. So, but before we go any further, I would like first of all to start off with a short video that Novamera has for us. So Stephanie, maybe you can roll that.
So sorry, give me just 1 second.
Okay.
So basically we wanted to create surgical or precision mining method for mining narrow ore veins that are very difficult to extract using conventional mining method. Here at Novamera, we have designed and developed a unique technology called NBIT, which stands for Near Borehole Imaging Tool. So the data that we collect while drilling allow us to create accurate drilling plans as well as drilling trajectories that maximize the ore extraction in a more efficient way. This technology is basically a navigation tool that allows you to track the vein.
The drill bit is the business end of the drilling. We use a pile-top drill rig to pull out and drill out all the ore. The way it drills out is by rotation and force.
This shows where the water is coming out of the drilled hole. Slurry system. And we're just continuously pumping water into the hole through our separation tanks and then back into the hole. And it's from these separation tanks that we excavate out the actual rock cuttings or the ore. So we're seeing the rock cuttings directly from the slurry, and the white rock is the quartz, which is the vein that we're specifically targeting with the drill rig.
Well, that's an impressive intro to your technology there. Before we dig into that, what got you into this? Dustin, maybe you can kind of share a little bit about how did Novamera even come to be? Sure.
Well, Ryan, think about this. Imagine you had $100 million locked in a safe and you couldn't find the key. When we were at Anaconda Mining, when I was the CEO there and my business partner, Alan Cram, was the general manager, that was the problem that we had. And it was at that site there that you see in the video. So the Romeo and Juliet deposit that sits about 1 kilometer from the operating mill, that was a steeply dipping narrow vein deposit and had about $100 million worth of gold in it, but we couldn't figure out a way to mine it. We looked at different open pit scenarios. We looked at underground scenarios, and we just couldn't make it work on paper. So we just knew it would never work in the field. So we started, or Alan actually, he started to talk to Memorial University. They had a drilling technology lab, and they do a lot of work in offshore oil. So we started to talk to those folks, and we eventually came up with the idea that ultimately became our surgical mining technology. And so we recognized that there was there's got to be a better way to mine better, more efficient way to mine these types of deposits. So we actually had to go out and create one.
Okay, so why is it not an Anaconda project still?
Yeah, interesting. So we had an aha moment, I would say, back in 2019 when we were developing this technology within Anaconda. We were at the Disrupt Mining contest, the one that was sponsored by Goldcorp, and we're actually a finalist. And during that process, after we finished on stage, and we were mingling amongst the 600 or so mining professionals that were there, we were talking to lots of folks, and they had expressed the fact that they thought our technology would be useful and could benefit them at their mine sites. And that's when the kind of light bulb went off. We're like, wait a second, this is a very similar problem to what we have at Anaconda. So it wasn't just an Anaconda problem, it was an industry problem. And then we started to look at sort of the potential of the market, the narrow vein market. And today we see it as, a 30 or $40 billion market across all commodities. And so we were like, okay, I think this is a situation where we should probably spin this technology out of Anaconda and set up a separate vehicle. So that's where Novamera came from. And, so we thought this would be a great opportunity to sort of develop a technology for the industry and address this unconventional mining and unlocking these types of deposits that were literally all around the world.
Okay, if I could kind of press you a little more on that kind of discovery and why Novamera came to be is, why would a mining company be interested in this technology you have?
Yeah, well, I think we're thinking about mining differently. We're thinking about evolving mining so that there's a long-term sustainable growth pattern for the industry. We feel like what we're doing can coexist alongside conventional mining, but conventional mining is starting to feel a lot of its limitations, and conventional mining is about leveraging economies of scale, and that's the way companies are moving in that direction is that these days in order to get the returns they're looking for. And with that, you're building bigger and bigger mines, and at the same time you're moving a lot of material. And that's created sort of four problems that are associated with conventional mining. First and foremost, you've got the environmental impact. Mining companies are in conflict now with stakeholders. Those stakeholders want the mining companies to change their business practices. And then, the second thing is that it's just getting harder and harder to find world-class mineral deposits and just to replace what you're mining at your current site. So, and that's in the context of the conventional mining method. So it's hard to find those types of deposits to fit that methodology. And then grade is declining. So that's the third issue, which we know then means you're moving a whole lot more material to get the same amount of metal output. And then the fourth thing is that I think what's kind of interesting to me is that mining companies have known mineral resources in their portfolio that they can't mine using conventional mining methods. And some of those could be those steeply dipping narrow vein type deposits where our technology could be applicable. So, we've got a solution now that can address some of these problems.
Okay, and we just saw that video. Some of that technology, as you call it, conventional mining, some of that looked a bit conventional. What makes your solution so unique?
Yeah, so what we're doing is we're employing our own proprietary navigation tools, and we're combining that with large diameter drilling to extract and surgically extract the ore body and leave the excess waste behind. So we're moving a whole lot less waste. We're using a lot less water. We're not using any blasting. And so it's just a smaller environmental footprint. And then economically, it's there's a lot of economic benefit. We're competitive on cost. we're faster to ore because we don't have all that development they have, particularly with an underground mine. If you saw in the video there, I mean, we were literally sitting on top of the ore, so we were drilling into ore at that point. So from a net present value perspective as well, you can move up your cash flows, and then even the optionality in how you mine, you've got a lot more flexibility, so you can sort of mine the higher value stuff first. And then again, to help with the value of your project. And then at the end of the day, it's basically mobile equipment, and so you can move that from job to job and site to site, so you can reuse that capital. So you get a lot of better return on your capital. In the case of underground mining in particular, once you build a ramp, shaft, or a portal, it's literally sunk. Like you can't take that capital with you and go somewhere else. So, it's just, so there's better economics. And at the end of the day, what we're doing is we're not competing against bulk mining. This is a low tonnage, but it's value over volume, right? We're not extracting a lot of waste. We're limiting dilution. So therefore, what you're taking out of the ground is the highest value ore that you could possibly take out.
Right. And I think there's a lot of companies out there that can say, they have these satellite kind of showings or deposits that, the conventional method just can't cut it in terms of making the grade, if you will, if I can use that pun. I think this may be a good point. I think we have our first polling question. This would be a good time to do it. So if you're in the crowd there, please have a look at this and put your comment down, put your vote in for this question. Still moving.
I guess as panelists, we can't vote and bias.
Yeah, it's kind of a little biased. Okay, it's still moving, so I think we'll just let it once it calms down. Then I think we can. Okay, I think that's no. Still more coming in. Okay. Huh?
I'm glad everybody's answering them.
Yeah, exactly. No, this is good. There's feedback is so powerful. So
if you want, we'll give it another 20 seconds.
Sure. I think it's stabilized there now. Nope. As soon as I said that, right? It's like watching the stock market.
Give like 5, 4, 3, 2, last shot.
Okay, excellent. Okay, thank you very much, Stephanie. I guess can I cancel that or close that? Yeah. Okay. So to continue on, maybe let's Andrew, you've been a little quiet in this conversation. Maybe we can bring you in. You're at the forefront of in the field with this technology. We saw for all the people registered, they saw Alan holding that bag, the first ore. That's a pretty exciting picture to see. Maybe you can bring us up to speed on kind of where you guys are at.
Yeah, sure, absolutely. Thank you for that. I mean, maybe I'll start a little bit by just explaining the approach of what we're doing, right? So very much like Dustin already mentioned, targeting steeply dipping narrow veins, we're introducing keyhole surgery, right? So very much how, as a society, we evolved from open heart surgery to less intrusive keyhole surgery to solve health and heart and other medical challenges. We at Novamera are evolving mining in a similar approach with our surgical mining approach. So to access these steeply dipping narrow veins, you need a high resolution understanding of the vein geometry. And then on top of that, the ability to follow that geometry. right? Because we know how easy it is to lose a vein if you're just drilling blindly. So we've developed a technology and a technique to achieve this, and it's a 3-pass approach that we have developed. In the first approach, in the first phase, we use a conventional core drill, an NQ size core drill, and while drilling with the core drill, we're deploying our imaging technology, and this imaging technology is doing that high resolution understanding of the vein geometry. It's building that trajectory. And we keep drilling along strike to keep getting this high resolution vein geometry. Then comes our second phase, which you saw in the video. We are using pile-top drill rigs. So these pile-top drill rigs then grab that geometry, grab that trajectory, and align themselves to maximize the extraction of the ore, and subsequently following that trajectory and drilling holes along strike to extract the ore. And then there comes the third pass, which is we then use the tailings and backfill all the holes that we've drilled. And essentially, we are now remediating the site as we are drilling in production and restoring everything back to its almost original state, as if we were never there. So, I mean, to bring you back up to speed as to where we are with our technology, we're working right now on our first generation of this technology, having just finished our proof of concept. So last year, we conducted our proof of concept, which was the entire 3 phases from start to finish. That's a little video clip that you saw at the beginning of this. Our initial focus for this proof of concept was to achieve 2 main objectives. We wanted to demonstrate the guidance technology, this high resolution imaging of the geometry, and essentially developing our guidance technology. And also our second objective was to demonstrate the ability to extract the ore using this mechanized method, such as the large diameter drills, the pile-top drill rigs that we're using. Again, just to demonstrate the evolution of mining, you know, moving a little bit away from traditional mining. And, you know, obviously my unbiased opinion, you know, as you saw from the video, our proof of concept was a great success, right? We achieved those objectives. But the real question is, well, why did we do the proof of concepts? Yes, we had those objectives, right? And the real reason why we did it was because we wanted to really demonstrate this keyhole surgery, right? It's one thing to say it to people; it's a whole other thing to actually show it to people, right? So in our proof of concept, we drilled 3 pilot holes, 100 meters deep, each pilot hole, a meter apart from each other, along within the vein, a long dip, and deployed our guidance technology and mapped the ore body, the geometry of the ore body. Subsequently, we moved into our second phase, which was we had a 1 meter diameter pile-top drill rig, and we drilled the initial 3 pilot holes with the pile-top drill rig. If you can think of the holes numbered 1, 2, and 3, with 2 being the middle holes, right? We drilled first holes number 1 and 3, or 2 outside holes. We drilled them. We reached a depth of about 90 meters at a 30-degree incline from vertical. We backfilled those holes, and then subsequently we drilled the middle hole, which was touching holes 1 and 3. Just again, giving an idea of time, we did this from starting of planning to actual execution and completion was exactly 12 months. We went from planning to on-site production and backfilling. Just to give an idea in terms of the importance of the imaging. as I mentioned, we drilled these three holes at a 30-degree incline, and we chose 30-degree because that is our maximum target in terms of an inclination for our first generation. So we're going from vertical to 30 degrees. So for cost purposes, being a proof of concept, right, we just put a fixed angle because we wanted to just test the ability to draw at 30 degrees. However, based on the information that we got on the geometry, even three holes, a meter apart from each other, had this been a production, cycle as opposed to a proof of concept, we would have drilled those holes at a slightly different inclination, somewhere at 28 degrees, somewhere, 27 to 29 degrees. So that's a real demonstration as to why you need this guidance technology, because let's face it, Mother Nature doesn't draw straight lines. So that's kind of where we are with the technology. We've now grabbed all that data from the proof of concept, and we're now taking all those learnings and we're incorporating them into our first generation offerings.
Okay, and that's interesting. So when you're talking precision, you're talking by the degree when you're looking at driving these, I'll call these holes.
Absolutely. Not to get too technical, but I am an engineer, so I can't hurt. If you start off the hole a half a degree off, you're going to lose the vein. Even if it's a dead straight vein, you're going to lose it within 40, 50 meters of depth. So yes, precision is absolutely needed to track the vein.
Right. So how is the industry responding to you so far with your idea?
It's been a really positive response. I think I could confidently say that everybody definitely sees the applicability. Everybody that we talk to, we've have lots of conversations where you get sort of the similar anecdote where you're talking to a geologist and he'll be like, oh, well, let me just go and back to my filing cabinet and dust off these 2, 3, or 4, or 5 deposits that we just kind of put away because we couldn't mine them using whatever method we were using. And now maybe I can bring those out and now maybe we can actually put those into production. So it's an interesting thing because we're unlocking mineral resources that haven't been mined yet. So you've got this. You got databases of known deposits and technical reports where you can find this information, but then you sort of have all this blue sky about, anecdotes like that where people are pulling stuff out that you never would have thought of before. So the opportunity to us is huge. So that was it's a great response to hear that. And we're just getting, as Andrew alluded to, now that we've done a field trial, and we're producing videos and pictures, and so people can actually see and see what's going on, understand better what it is, and it's prompted them to ask more questions and learn more. So we have lots of conversations just because people see what is actually happening on the ground, and we actually were able to bring people to site. So we had Sumitomo on site last fall, and we actually had a major gold producer that visited as well. And just happens one of the representatives of the major gold producer, literally said, I think you're really onto something here. So, that was quite pleasing to hear. So we've been able to build a pipeline of interested parties, and we've actually been doing work, analytical work, desktop evaluations with companies, and now we're even talking about field trials with certain companies. So it is starting to gain momentum. So we're very pleased with that.
Right, and like to say the video of doing that field trial, making it real, as I would say, huge milestone for your company. I was enjoying those that poll, so I think we actually have a couple more polling questions before I get one last question, then we can open it to the floor here. Let's do we have a couple more polling questions there, Steph? Okay, what's this? Where do you think our technology is most applicable for you? I really like that. I like the engagement we had last time, so that's good. Here we go. People giving it some thought. Maybe we'll give it 10 more seconds, Steph, and
Perfect.
yeah, and there's one more question you want to put there. Yeah. Okay. Why don't we close that one? Okay. What's this? Where do you think our technology is most? Oh no, that's the one they just asked, right? Is this one close? Okay, there we go. What would you need to take the next step to try our technology? Oh, okay. A little more directed.
Since we've got the audience, we might as well ask the questions.
Well, yeah, no, that's good. And I really appreciate the participation by the audience. This is good. This is. Yeah, this one's a little more specialized, so I think well, got a couple more coming in. Good. And we'll give it 10 more seconds here, Steph. Oh, someone's going, wait. Oh, okay. All right, good stuff. Okay, thank you very much, Steph. I was going to ask that question actually, and when you were talking was the and maybe this kind of ties into maybe my last question to you is you know, what's next? Because part of me was, I saw it on the surface, I can really picture that, but I'm trying to see it and visualize it for underground, because it could make sense. We all see mines where ore bodies start at the 300 meters underground or plus, right? So maybe I'll combine this question here is where do you see yourself going now, and maybe you can answer that underground question at the same time.
Yes. Oh, well, Andrew, you want to take the underground technology side of this?
Yeah, so I mean, from a guidance technology perspective, I mean, there isn't much that we would need to change because it's the same guidance from at surface to the underground. It's the drilling aspect that would need to change and the approach to change it. So we have a roadmap of how to get to the underground because we've heard the feedback already from a lot of the customers. So right now we're focusing on our first generation, but accelerating our roadmap to be able to get this technology down into the underground.
Okay.
And then just overall, we're as Andrew mentioned before, we're finalizing our first generation system by the end of this year. And in 2022, we also have some other key milestones. We're working on case studies to be able to provide to interested parties, interested customers, so they can get some metrics and get a sense of the applicability of our technology, and so that'll be coming out pretty soon. We're working on proposals for field trials. We actually have an exciting one that's just been launched with the Canadian Mining Innovation Council, CMIC, where we're doing a field trial of the imaging tool. And right now we have a large cap gold producer that has signed on essentially to be the lead order. So we've got somebody already in the consortium, and we're working on adding just a few more folks to that to be able to kick it off and do the work by roughly late summer, early fall. And then we're also going to be from a financial perspective, we'll be out raising capital again. Basically after the summer. We've got about a runway till the summer of 2023. but it's never too soon to start looking for your next round of financing. So we got a couple of things on the business development front and on the technology front, but 2022 is going to shape up to be a really good year for us.
Okay, that's exciting. That's exciting news. So I'm not gonna. I want the crowd. They came here to listen to you and probably ask some questions as well. But before we do that, I think there's one more poll question. Then that's it. I promise. And then we'll open the floor to questions. So after listening to this one, are you curious to know more about Novamera's unconventional mining technology? And it really is unconventional. I like that word. You know, it's when I first saw it, I was like unconventional, but now the more and more I've heard from you and everything, unconventional makes sense completely. So. And I guess with regards to that consortium, if companies are interested, just reach out to you, Dustin, directly and see if they'd like to be a part of that. Okay.
Yeah, and they can also feel free to reach out if they just want to do it on their own with us.
Well, of course, yeah.
Either way works for us.
Yeah, well, why not? If you can untap and unlock some, you know, sub-economic deposits and become incremental feed to the main ore body, why not? So.
Exactly. Yeah. And we've got we've got the ability to do multiple imaging tool field trials this year. So it's we certainly have the capacity and the resources to do it.
Right.
And it's a great way for companies to really start to get their head around the capabilities of the entire technology package.
Right. Okay. Well, you know, I've got lots of questions, but let's open it up to the floor there. If you have a question you haven't put in the Q&A, please do. And Stephanie, maybe you can do that.
Yes, we actually already have some questions. So let me just start with the first one that I received. When can I do a field trial of your technology at my site?
Yeah, I mean, in terms of a full field trial, actually, you know, very similar to the proof of concept trial that we did. It took us about, 6 months of planning to get to site. So I would say if you're interested in a full field trial and are thinking about it right now, target would be kind of spring of 2023. Once we together establish, what the objectives are, that's kind of how long it would take us to do the planning and to secure the drill to come to site. So yeah, if you're thinking of a full field trial, I'd say spring of 2023.
Wonderful. Then I have another one. It says, can I try the NVIT before doing a full field trial?
Yes, yeah. So the NVIT, that's our near borehole imaging tool. So that's the key enabling technology in all this. And yeah, you definitely can. I think we're actually encouraging companies to engage in sort of a stage gate approach to trialing our technology. And we've got a whole program in place that includes things like doing desktop studies, moving into lab testing, then into the imaging tool field trial, and then a full-blown field trial, so that you gain some experience, understanding along the way, and sort of have sort of lower cost, lower risk type activities, so you gain that confidence in what we're doing, and we learn together as we go. So that by the time we get to more of the big ticket items, you can feel good about sort of getting to that stage. It's an easy way to start, and then certainly the stage gate approach enables you to stop at any point as well. So you don't have to do it all, but you can certainly have a path laid out so that if you do want to, we know what direction we're going in.
And that, I think that makes perfect sense, because that's half the time that blindness, if you will, about the dimensions of a vein is critical to determining, okay, is this even worth trying, right? Because what we see at surface or what we say at the beginning may not be in the middle let alone at the end. You know, even if you could go from level to level underground, many a times things have pinched to nothingness before. And so it helps you really kind of do the economic analysis before a full commitment, which is very powerful.
Yeah.
And maybe just to tack on real quick to that, right? Like we have 2 working prototypes of the NBIT in our hands. That's what we've been using ourselves for testing, and they're deployable on a traditional NQ core rig without any modification to that core rig. So, you know, if you're interested in testing this imaging technology, you know, our time to site is very quick.
Excellent.
Right, we have another one. Do you plan to vary the diameter of the large diameter hole as you drill so you can be more surgical and extract a variant diameters through sections where the vein may be wider than the base drill bit diameter?
Yeah, so I mean, with regards to the large diameter drills, this is where our expertise comes in, and you know, because it's always the large diameter drills, especially the cutting at the business end, as I like to call it, is always going to be tailored to suit the project. So introducing features like that, like under reaming ability to the cutting edge, is a definite possibility. And again, it's not something new to industries, you know, under reaming on drill bits. So absolutely, you know, once you get the information about the geometry and the guidance of that geometry, then you can make those decisions about what kind of drill bit, what kind of cutting head, what kind of options do you need in that cutting head to, again, always maximize the amount of ore that you're pulling out and minimizing the waste. So absolutely.
So that's the width aspect. How about the orientation part? What if you get, you know, something that's undulating a bit, and how do you chase something like that?
So with the guidance technology, before we even start drilling, right, we have the ability to calculate the trajectory that optimizes the maximum amount of ore recovery. And you can vary this from hole to hole. Our entry sleeve that we have designed has that ability to. It's not a fixed trajectory. Our first generation is going to be drilling straight holes, but again, you can change the inclination of those holes to maximize the ore recovery. But it's always, even when we get to the point of steering, when you get to a large diameter, you know, there's only a certain amount of steering that you can get. So finding that optimal trajectory is key. And part of finding that optimal trajectory is also the diameter that you're drilling with, right? Is varying, using different drill bit diameters in different locations to minimize the amount of steering that you need and capture the most amount of ore possible. So a lot of, you know, everybody's perception is always, oh, well, I need to, you know, steer and be able to track it. Well, you need to know where it is, and then there's many options of how to skin the cat of how to get it.
Right. Good.
We have another question from Jason. What key things for the drilling will you need to change or adapt to go underground?
I feel like you're throwing all the questions my way. Maybe we should.
All technical.
Not a problem at all. So I think, like, right now, the one key feature I would say we would need to change is really moving away from a pile-top drill rig to a different drilling technology, simply because the pile-top drill rig, as it stands, needs an envelope of about 8 meters, which is relatively big for the underground. And again, as I mentioned earlier, our roadmap of how to do that is in place. Technologies from different industries already exist. People are drilling underground, even with large diameters, from industries like, you know, microtunneling or tunneling itself. So there's lots of industry expertise that we can pull in, but the majority of the things that we would need to change are really on the large diameter drill side of things and how we handle the material.
Wonderful. Okay, another one. what key areas of technology do you believe you need to develop and require funding for?
For our first generation, we were funded in terms of bringing the first generation to the market. I'd say the next round of financing that Dustin has already mentioned is actually going to be focused predominantly, I'd say, on accelerating our underground roadmap. I mean, that is still in flux. We're always, addressing what is needed for the industry as we get feedback from the industry. So that's what I would say in terms of our next round of financing is really right now targeted at accelerating that underground roadmap.
Yeah, and our financing it'll be a combination of traditional equity financing, venture capital financing, as well as government grants and things of that nature. We've been fortunate thus far to be able to access government funding at both the provincial level early on when we were in Anaconda, and then at the federal level during our Novamera days. And we continue to get a lot of positive responses from government funding sources within Canada that see the potential of our technology, and there's opportunities to acquire funding for projects such as creating the underground solution.
Good.
Okay, another question from Patrick. When will you increase your depth, and when will you come to Fiji? And can I join you when you go to Fiji?
I should say, man, nice invitation.
Do I have to go to Fiji for work, or can I just go?
So was that the depth, how deep we can go? Is that what the question was?
Yeah, when will you increase the depth?
Right.
Okay, I don't think
So-
we got the max yet, did we? Did we talk?
Well, yeah, maybe I can, address that. I mean, right now, for our first generation, our max target depth is 300 meters. And that is because today the pile-top drill rigs have predominantly been used in that range of depth. However, I must stress that it's really project specific. Of course, if it's a much bigger number, then that requires some further development. Which, by the way, is again on our roadmap to be able to increase that 300 meters depth to a much deeper target on our next few generations, but it's really dependent on the inclination that you're drilling. That 300 meters depth would be a much different number if your vein was very vertical. So right now the number, just to have a number, is 300 meters at 30-degree incline, and we're going to increase that on the next generations. But I must stress that it's really dependent on the vein geometry.
Right. Go ahead.
Sorry, I was going to say, and also too, the way that we look at the technology development is in conjunction with the market and the market potential. So, one of the key things that we are doing is we are talking to companies about, understanding better what could be an underground solution, because we get a lot of feedback about that. So, we're evaluating our development path for our technology alongside sort of where the market really wants us to go. We potentially could go deeper, or we could have our surface application right now that goes to 300 meters, and then we start working on an underground solution. It really be dependent on that. It's just an evaluation and analysis that we have to do that is ongoing.
And I might have missed it, but you did the depth. How wide do we think we can go with this thing?
So this is, right now we're targeting 2 meters wide as a diameter. It's the most economical diameter, but it really depends on the vein width. However, I must again, stress, these, like the pile-top drill rigs that we're using, they go up to 8 meters in diameter, and other industries and previous experience that I have, even going larger diameters than that. So right now for our first generation, our focus is the narrow veins, the steeply dipping narrow veins, right? So we're targeting the 2-meter diameter. But yeah, these drills that we're using can go much larger.
Yeah, I mean, we're again coming from the market side. I mean, we see a robust market at the diameter that we're at right now, and you know, it's one of those things too where, as a technology company and a technology developer, you know, we kind of want to crawl before we walk or before we run. So you know, we want to master what we've done now and deliver a, you know, valuable solution to our customers, and then as we grow and mature. We'll determine sort of the next markets that make sense and be able to leverage our learnings and what we've already developed to be able to get into those markets in a bigger way.
Right.
I see, I just see a question from Bruce, and I think it's important because Bruce is asking, you know, when we're talking about geometry of the vein, is it in 3D space? So I'll stipulate that, yes, our guidance system, our geometry, that, you know, when I talk about geometry and the guidance technology, it is 100% three-dimensional space. So
Okay, thank you for that. Yeah, I will be reading the questions first on the Q&A, and then I'll jump into the chat, the questions on the chat, just so I don't miss any. What is the composition of your drill mud?
So in terms of production drilling, we don't use any drill mud. The production drill itself is purely water-based. So it's a reverse circulation system, a closed loop reverse circulation system that uses water and compressed air to pull the material out. So from a production sense, we are not using any drilling muds. It's purely water, and the hole is full of water as we are drilling. So I'm assuming that's what the question was targeted at, is the production drilling side.
Okay, what diameter in inches is the large pop-up drill hole?
Well, I think that's what we're just talking about, right?
Yeah.
Yeah, so
What's the
in
difference?
inches, yeah, in inches right now it's about 66 inches, if my American to Canadian is correct, but it's 2 meters.
Okay. What sort of minimal size deposit in terms of gold ounces content or NSR value should we consider to introduce your technology at an existing site?
Yeah, I mean, there's a lot of it depends answers in there. It's certainly going to depend on the grade. You know, we're going to be we have a couple of case studies that we've done already, and you know, I can tell you that one of them in particular had a pretty robust return, and we produced about 130,000 ounces of gold over about 5 years. So you know, when you think about you know, project sites that are looking to create or have a desire or need to do, you know, a lot of production to justify infrastructure and fixed cost overhead, you know, this technology enables you to really put into production smaller type deposits, and you know, so those periphery deposits, those add-ons, you know, they're truly economical at smaller levels.
Yeah, because you must be getting down. You must have a substantial drop in your cost per ton from a conventional mining perspective.
Yeah, it's the operating costs are really competitive, particularly against underground mining. You know, it's sort of the narrow vein, you know, cut and fill, those types of selective mining methods. Where it really becomes eye-opening is on the development side. I mean, our development cost is near nothing. I mean, as you saw from the video, like, we're not building a ramp, shaft, or portal, or you know, open up a big pit or anything like that. We're literally right into ore. So that development cost, you know, goes away, and then you've even got downstream savings where, you know, the product size that's coming out of our drills is going to be at a size that we believe you can possibly eliminate your primary crush. So you don't have to do that, and then in our process, the third stage in our process is to backfill the holes, but we're backfilling them with the tailings from the processed ore. And so you don't need to store that. It's going back in landform tailings. And we get roughly about 60%, we estimate, in our first generation solution. So you really reduce your reliance on constructed tailings facilities. And we all know how costly those are to build. And then certainly the liability associated with them, not only just in sort of bonding them, but then the time that you're under the gun with them. There's a lot of value in not having those big tailings facilities. Oh. So the costs, it's pretty impactful, and that's what enables us to generate some really good internal rates of return on projects, because you don't have a lot of upfront capital, and you're pushing your cash flows up.
Right.
During pass 1 or pass 2 or both, are you employing directional drilling, steering while drilling to follow the vein, or drilling along a straight line?
Yeah, so for our first generation, we're drilling on a straight line. And subsequent generations will start introducing some steering to further improve the economics. Having said that, when it comes to our first pass, our imaging technology, we don't need to steer, because with our imaging technology, we're able to see up to 3 meters outside of the actual borehole that we're drilling. So even if the drill all of a sudden is outside of the vein, we can still track that vein up to 3 meters outside of us. So we don't foresee the necessity of steering the first phase, the pilot hole, with our imaging. We'll be introducing some steering on subsequent generations. Again, I must stress, having come from a large diameter background, there's this perception that if the vein is going in different directions, I have to steer. That is far from the case. You can have an orientation of a vein that's all over the place, and yet capture a lot of the ore, even by drilling a properly targeted straight hole. Because even once we introduce steering on these large diameters, you're talking about a 2-3 degree steering capability.
Right.
How far away are you from testing and also implementing turning on the drills?
I think we've tested what we've tested so far in the field back last year was the full solution. Correct. So we've done pilot hole drilling, imaging, and we've done the large diameter drilling and the backfilling, and subsequent to that, even earlier in this year, we've done more imaging testing in the field as well. So the entire system has been tested, and now we're making tweaks and trying to improve in areas where we see that we can.
Thank you. Let me just read the last questions that I have. There's many questions. That's really good. Let's see, I'll go all the way to the top. I think we already answered the diameter in inches for the large pop-up. Please confirm if the spring 2023 field trials are for straight holes. Also, when do you expect to start trials with steering?
Yeah, so the next field trials in the spring will be at a 2-meter diameter straight holes, employing a lot of, as I mentioned, and I kind of keep stressing, the targeted trajectories of where we're drilling. In terms of steering, that is currently on our roadmap, both in the underground solution and on a steering second generation solution, which will be which right now we're targeting the end of 2024.
And I'll just clarify too, for 2023, What we will have included in our solution is the ability to do course correction. So we're going to want to stay on a straight line, but we do experience deviation, particularly for gravity. So we'll have technology included in our solution to be able to keep on that straight trajectory. So even in the first generation, we are starting to introduce the concept of steering, but it's limited to what we're considering course correction, just to stay with a straight hole.
And I would just add to it is what I think is, if someone's saying, well, no, I'm going to need something that requires the steering second generation, they should reach out to you and say, hey, this is my situation, and let you guys are kind of the experts in this now, so let you guys figure it out.
Absolutely, 100%, because as I mentioned it, and this is part of the offerings from a desktop evaluation, right? Is demonstrating even though it's first generation, how much ore can be extracted with the first generation, because there's many levers that we can pull, in terms of the right trajectory, the right drill diameter, changing that drill diameter, quite frankly, just to give you guys some insight, I mean, our very first initial approach was that the drill diameter had to be the width of the vein, and that quickly changed even with our own knowledge. So now we target the width of the diameter more strategically to optimize the extraction.
Yeah, and Andrew mentioned the desktop studies. Well, our desktop study is not just an economic analysis. We do a full 3D mine plan. So we lay out the holes, and so that to maximize the ore recovery. So if there is a concern about being able to recover enough of the ore because there's lots of undulation in the ore body, well, we can model it and see what the maximum amount is. So we've got that capability, and we take that information and we bring it into our financial model so that we can provide a complete picture.
And just to wrap up this question, and to your point as well, in terms of, should they approach us if they think they have a vein that requires steering? I would say absolutely yes, even from a perspective of limiting even maybe to an imaging test, because let's face it, the current models that that exist are based off 25 meter spacing at best, and the geology can the actual ore geometry can be significantly different, right? So even if you believe or it is truly the case that the best option for you is to wait for that second generation steering, I would say getting up to the point of doing an imaging test with us, or starting to do that to get a better understanding of your own geometry, get again that higher resolution geometry from our technology, is a lot of valuable information.
Great. Bruce has 3 questions. I'm just going to go one by one. I'm sorry if I've asked this before or not, but what is the max depth best case scenario?
It's 300 meters, right?
Yeah, I'd say
meters,
300
right?
meters, yeah.
Yeah, okay. Can pilot hole and extraction holes be steered to follow varying geometry down dip?
Yeah, I think we talked about that just
Yeah,
now.
that one too. And then we talk about 3D space.
Yep.
Okay. Hello there. I am Ahmed from Bangladesh. I was a member of MUN Drilling Technology Laboratory and working SMT project. Are you using CCS disc cutters for LDD? And is the particles are well sorted?
Yeah, so in terms of the large diameter drilling, again, this is the configuration of the cutting head, the type of tools that we use are really driven by the geology. This is again another factor of the expertise that we bring to the table. The type of ore bodies that we're targeting right now, those really hard rocks, yes, we're using disc cutters. carbide insert disc cutters, but the configuration of those is significantly dependent on the geometry. And actually, in terms of the particle size, and Dustin touched on this a little bit, we to a certain extent, we actually have control on the particle size that's coming out, because we can tailor and design the cutting head accordingly in terms of in various ways. Yeah, we have control over the particle size that's coming out. In terms of, I'm not sure exactly what they mean in terms of well sorted, but yeah, we've got control on the material that's coming out to a certain extent.
I just worry that we're at our 1 hour mark. Are you guys still good to continue on as well? I know you want to answer the questions, so okay, go ahead, Steph.
We only have 2 more questions and then we're done. Pat, I was a bit late, apologies. As it might have been discussed, what is the shallowest deep end goal it can tackle?
Yeah, so based on the drilling technology we're using today for our first generation, I'd say that's 30 degrees from vertical. Once you start getting shallower than that, you need to use some different extraction methods. But so for now, for the first generation, I would say 30 degrees from vertical.
Awesome. And the last question from Ben. So the SMD bead doesn't need to follow the end bead borehole?
Correct. No, it does not. So the imaging of the pilot hole, where we're gathering all our imaging and high resolution guidance, is building a trajectory for the large diameter drill. So the large diameter drill, your production drill, does not need to follow a pilot hole. It's going to be given its trajectory, and then based on the course correction and the entry sleeve that we've developed, the guidance information gets fed into there, and that's how we target the location of the large diameter drill.
Great. And we just received the very last one from Wayne. Is it also absolutely necessary to utilize a reverse circulation method employing water for your drilling process, or is it feasible to use a purely air-based dust drilling method?
So again, there's a lot of different ways to do it. Our focus right now is on the reverse circulation because it's extremely efficient. However, again, based on the project, based on the geometry, using things like vacuum or forced air and not having any water is a possibility. It's not what we're focusing on today, but it's definitely a possibility, and definitely something that can be looked at to be customized.
Well, and I would say, and if there's a client out there that's very interested in you solving that puzzle, for them to call you, and
you're right. It's nothing new to the industry, right? I mean, drilling with vacuums and using vacuum as a suction, it's probably going to limit you on depth. Supplementing that with compressed air is an option as well. So there's many ways to do it.
Yeah. Is that it, Steph?
That's all the questions. Yes.
Okay. Well, this has been a real pleasure having you guys here. This is exciting technology. It is a game changer in the sense of, as you put it, being unconventional and drilling. So thanks for sharing with us where you guys are at. And it's exciting to see your roadmap, and looking forward to hearing back from you guys with the next milestone you reach.
Yeah, well, thanks for hosting, and thanks to everybody for joining. We appreciate it.
Yeah. Excellent. Okay. Thanks, everybody. Take care.
Bye.
Have a good day. Bye.